Okay. So to
This
start
call is
with
now being recorded.
uh, today's class, okay. So in the first class, I have already told you that before going into the uh, details of this group multiplication table or group theory, you are supposed to know some of the rules, okay, which even these symmetry elements are going to obey, okay. So in that I have told you already, we have done this in the first class, just I'm giving you the first rule is, because in this connection I'll be talking today. So the first rule is closure rule. When I'm telling that you are talking about a closure rule, that is, if I am doing a product of element A and B, if I get a product C, okay, as an answer, this C should be a member of the point group, okay, of the same point group. So if I do any two symmetry element product, okay, whatever answer I am getting, that should also be a part of the point group, okay. Suppose if I have the water molecule, what is the point group of water molecule? Hello, girls? Water molecule point group? You need to talk to me, girls. Hello? Hello? Yes? Aparna, Kamali, Monica, Shruti, anybody?
Madam, I couldn't hear voice properly, madam, because of my internet problem.
Okay. Can you hear me now?
Yes, ma'am.
I'm just asking, what about others? Are they present or not? Aparna?
They
Monica?
are present, ma'am.
They're present? Okay. I'm just asking point group of H2O molecule. It is C2B, right? If you have
Yes,
forgotten.
ma'am.
Ah, C2B. So in between, I'll be asking questions. You can unmute your mic and answer me.
Okay.
Okay? Yeah, because this is an interaction. This is not me only talking, it is you also answering. Okay?
Okay, ma'am.
Okay. Then only it will be interesting. So when I'm telling a closure rule, so in the water molecule, if I take C2B point group, okay? So if I do C2 multiplied with something, what are the elements in C2B point group? We have identity, I have one C2 axis,
Okay.
and I have two sigma
Mommy.
V's, right?
Yes.
Can you hear me?
Yes, ma'am.
Yeah. So you have uh, identity, you have one
C2.
C2 and two sigma V's, right? One is a
Yes,
molecular plane and one is a vertical plane. Okay. So if I do any product, for example, if I do some C2 into some sigma V, the answer should be, if I get a C, that is, it should be a molecular plane. So it should be a part of the group that you understand. Okay. So any product, if I do, the answer, whatever I am getting, that again, that should be a part, that should be an element which is present in the same point group. Then that means you are closing that point group. So you call it as a closure rule. Okay. Then, so you have an example here. You have done all these things. One more is associative rule. That is, whichever way you do association, you should be getting the same answer. That is, either you associate C and B, or A and B, or C and D, or B and C. The resultant should be same. Okay. Here they have given example. Identity rule is, if I might do the product with the identity, whatever element that is there, the same element will come. That is the identity. Okay. Inverse rule, I just want to talk a little bit on this inverse rule. Okay. Inverse rule is the one when every element is a reciprocal of, has a reciprocal of itself. Okay. Suppose if I take an element A, okay, and its reciprocal is R. So if I do A, what does A represent? Some symmetry operation. Okay. So some symmetry operation or symmetry element, that is, it may be a C2, it may be a sigma V, whatever it is. Okay. And if I do a reciprocal of that, what happens if I take C2, I rotate 180 degrees. What will be the reciprocal if I rotate it back? What will happen? I will get the same structure, right? Once I am rotating 180 degrees, again I am doing the reverse of that. That is, going back to my original position. So if I do A into the reversal of that, at the end of the thing, I am going to end up with the identity, that is doing nothing, right? So this A, if it is having a reciprocal R, and if I do a product, or if I do a reciprocal first and then do the C2 or whatever the symmetry operation is there, again I'll end up in a identity element. Okay, so this is your reciprocal. Okay, now we will see here one example. Reciprocal of C3 1 is inverse of that, minus 1. Okay, that is equivalent to C3 2. We will see how it is C3 2. Okay, so first what we are doing? We are doing C3 1. Okay, then we are doing C3 inverse. Okay, and you should get a 1 which is nothing but your C3 2. Okay, that is what is we are telling. Okay, so you have to remember is whenever you do reciprocal of its own element, you are ending up with the E. Okay, now we will talk about the main topic for today, that is group multiplication table. Okay, so to write a group multiplication table, that is GMT, you should follow certain rules. Okay, that is the table should contain some rows and columns, so you call these as rows. Okay, and the vertical ones as the columns. Okay, then what else we will tell? Now this is represented in the form of Latin squares, we call it as. Okay, and one thing you have to keep in mind is, whatever element you are writing, okay, either E, A or B, it should be repeated only. It should not be repeated, it should be appearing in the square, Latin square, only one time. That means if I write E here, it should not come here and here, here and here. Okay, either in the column or in the row, it should come only once. Okay, that you have to remember. So remember this point, because we will be doing the construction of group multiplication tables. Okay, so the main thing you have to remember is whatever element you are writing, it should come only one time in a row, if you see, or in a column. It should not repeat, then it is not called as a group multiplication table. That is what you have to remember. Okay, so we will take up one example. Suppose I am talking about a simple one, that is having three elements, E, A and B. Okay, now this E may be your uh, identity. Okay, and this is the first element. So any group multiplication table, you should remember one more point is it should start with E, because E is the trivial or the important element. Okay, so it should, the row as well as the column should start with the identity element. Okay, now we will see what are the products. So if I tell that one of the point group, okay, if I take this example, one of the point group here, okay, is having three elements. So the order of the group is 3. So what is the elements? What are the elements? E, A and B. Okay, so same thing I have to write in a column, E, A and B. Okay, so now just see, what did I write here? I have written G1. Okay, that means this 3 superscript is the order of the group, 3 elements, right? So it is 3. Okay, J is the point group, and 1 is uh, one type. That means you, how many ways you can write the group multiplication tables for this particular point group. Okay, so if I write 1, it is the first type. 2 means second type of writing the group multiplication table. Okay, are you all following? So
Yes,
just,
ma'am.
yeah, good, good. So just see here, what will I do? I will do the multiplication of the column into row. Okay, so we'll just follow the same order, column into row. Okay, so E into E, we know that identity rule. So that's why I've just given you the rules till now. So anything multiplied by identity, I will get the same element, right? So that was
Yes,
identity rule. So E into E is E, E into A is A,
A.
E into B is B. Okay. Similarly, this column also you can see E into E is sorry, A into E is A because I am multiplying it with identity. B into E is again B. So this part and this part have already fixed now because here I am multiplying with identity, same elements will come. Here again I am multiplying with identity, same elements will come. Now look at this column. I have E, A and B. So none of the element has repeated, right? They are appearing only one time. Now look at this one. Here also it is E, A and B. So they are appearing only one time. A is only one time, B is also coming at one time, E is also one time. Okay. So they are not repeated. So if it is repeated, it is not a group multiplication table. So we have to take care that whenever we are doing this multiplication, see that the elements are not repeated. Okay. Now this part is done. Now we are having empty spaces here. How to fill them? So what is that? A into A, I have to write it as B. A into B, we are taking it as E. So the way to fill this is, what is the rule I have taken? I have taken that A into B or B into A should be equal to E. A into A should be equal to B. B into B should be equal to A. This is the rule I have taken to fill up this. Other than this, if I do anything, it is going to repeat. So what I'll do, I'll just take the empty sheet and show you how it is going to. So you can see some white background, right? So we'll just write the same thing. Okay. So what was that? It was G3, right? So G3 first type. Okay. So the element was E. Okay. Then you had A. Then you had B. So three elements. So order of group is three. Now here again I have E. Here again I have A. Don't know why. And B. Okay. So what did we tell? We said that we have to follow the rule that A into B
B.
should be B into A. This rule is known as commutative rule. Okay. So whenever I am writing this commutative, okay, A into B should be equal to B into A, and that should be equivalent to what? Then I said you have to write
E.
A in A. Okay, that should be equivalent to what? Then we have B into B. These are the things I have to address here so that I can easily write the multiplication table. Okay. So first we'll do this one. A into E is E. Okay. E into A is A.
A.
E into B is B.
B.
Okay. Now A into E is E.
A. A.
Sorry. A. Good. Then A into A is, we should know from
B.
here.
B.
A into B also I should see what is this. Okay. Now B into E
B.
is B.
B.
Okay. Now only for these four places I should have a rule. Okay. It should satisfy such that I should have the way in which I am not going to repeat the element. Okay. So A into A I will get only once. Let me make it as B. Okay. And B into B I will get only one time. Let me make it as A. Okay. So A into A I will write it as B here. Okay. Then B into B I will make it as A. Okay. Now in a row, what should be the elements? A, B, and what is left out now?
E.
E. Can I write A and B here? No. I'm supposed to write only the third element, that is
E.
E. Here also again I should write only the left out one, that
E.
is E. ఇక్కడ B ఉంది, A ఉంది, ఇక్కడ కూడా A ఉంది, B ఉంది. So again there should not be any repetition. So we can write that AB is equal to BA, which is equal to the identity element. So this has to follow this rule. Okay, then only we are telling that it is a proper group multiplication table. Okay, so this is how you have to write. Okay, now I'll take one more where the order is 4. Order is 4 and 4 elements ఉంటాయి. Okay, now for this the first type I'll put the order 4. Okay, so what is the first element I should write in any group multiplication table?
E.
E. It is the trivial element. Okay, so I have E. Okay. Other elements are A. I'll do one thing. And top one only I will write. It becomes easy. So what we are telling? We are talking about the so 1, 2, 3, 4. So I'm talking about the order is 4. Okay, and this is one type of writing. Okay, now we will see what happens here. So one more thing is C. I should write same thing, right? E A B C, E A B C. Okay, let me fill this. మీ దగ్గర paper pen ఉంటే you also sit and write that. Okay. Okay. Now see what I should write here. Anything multiplied by identity, I will get the same element. Okay. So I will, what should I get here? C. Right? Here again I should get?
C.
Hello? Yeah. E A B C. Because I am multiplying this with E. So I will get C. Kada?
Yes.
Yeah. Now we are left with 1, 2, 3, 4, 5, 6, 7, 8, 9 places you have to fill. Okay. And what is the rule I should follow now? What is the rule I should follow so that I will not repeat the elements? Okay. So what I'll do is I'll write it as let A into B is equal to C. Okay. Then A into B or B into A, I will get C. Okay. A into C, let it be as B. Okay. Then one more. What else I will have? B into C,
B into C.
let it be A. So what I have done, I've seen that when I'm writing this, I have written all the ABCs. Got it? I'm taking this rule now. Okay. ఈ రూల్ తీసుకున్నప్పుడు ఏమవుతుంది? Just see this. Okay. So A into B, where do I get A into B? A into B. So what should come here?
C.
C. Very good. Okay. Then B into A into C.
B.
B. Okay. Now this one. B into A.
C.
C. Because these are commutative. Okay. A into B or B into A. Same thing. Then B into B we didn't talk. Then B into C.
A.
A. Okay. Now coming to this one. C into A.
B.
B. Very good. C into B.
C.
A. C into C I didn't talk. Okay. Now what is the element that is left? In this, if I take,
B into C.
what is the element which is left?
A
E, right?
into A.
E is
Yeah.
left, right?
E, ma'am.
C ఉంది, B ఉంది, A ఉంది, E ఒక్కటే లేదు. దీంట్లో కూడా A ఉంది, B ఉంది, C ఉంది. What is not there? E is not there. Here also E is not there. So I should write such that the element should be appearing only once. Got it? So I can write that. So from this table I can write one more rule that A into A, what did I write? A into A is equal to E. Okay. B into B, I have written it as again E.
E.
Okay. Same thing equal to P into. Okay. So these two rules are the rules which we should follow. Okay. So for this type of writing the G1, okay. So just go to the notes. So okay, we were talking about G4. So G4, what did we tell? We should see that AB equal to BA, which is equal to C. Okay. AC, CA equal to B, BC equal to CB, which is equal to A. Then later on, you will see that on the diagonal, you have all the identity elements. Okay. There is one more method also to write this. Okay. That is G2, 4. Okay. In the first type, every element is a inverse of itself. Okay. That is the reason you are getting A into A as E. Okay. So I will take the second one, wherein we are taking that this is the thing. A into B, B into A is equal to C, AC, CA equal to B, and the last one, that is BC or CB, is equal to E. This is the one we are differing. Okay. So I'll make a note on this again. Just remember this. What is that we have done? AB into BA is equal to C, AC into C is equal to B. But when I have done BC, I should have written it as A, but we are writing it as identity. Okay. So that means A into A only you will get the E, other things you will not get. Okay. Just we'll try to write that group multiplication table. Go to the Jamboard. Okay. I'll take the uh, next screen. Okay. So we are writing the group multiplication table. Okay. Now I have G4 type 2. Okay. So I have E is the trivial element. Okay. Then I have A, first element, second element, B as the third element, and C as the fourth element. Okay. So similarly, you have here E, A, B, and C. Okay. Now we'll try to fill the other elements. Okay. Now, what is that we said? The rules I have to follow is A into B is equal to B into A, which is equal to C. This rule we followed in the first time also. Okay. Then we are telling what is the other thing I said?
A into C or C into A
A
is
into
equal
C
to B or C into A.
or C into A product of B. Yeah. So this will be B. Okay. Now the last one I said that B into C is only changing
B into C.
is equal to CB, which will be equal to identity. Okay. So before filling this, now just look at the first row what I should write. Okay. Anything multiplied by E is
E.
the same element. So E, A,
A.
B, C, right? Here also I can fill the same way. A, B, C. Okay. Now I am left with these things. Okay. So I will see A into A. We have not written here, so I will not talk about that. A into B is C, right? A into C is B.
B.
Okay. Now B into A. B into A is C.
C.
B into B, we didn't talk about that. B into C,
E.
E.
mm. C into A,
B.
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 C into B,
E.
E.
E. And C into C, we didn't talk. Okay. Now look at this row. What is missing here? Which element is
E.
missing?
E.
E is missing. Okay. So what will I write? What is the rule here when I tell that A into A
A
is
into
nothing
A
but
is equal to E.
E. Kada? So I'll just write that rule from this thing, that is A into A is equal to E. Okay. Now look at the other thing. B into B. ఇక్కడ ఏం మిస్ అయింది?
A.
A.
A is missing. Okay. What is missing here?
A.
What is missing here? A.
A.
So what did we write? B into B is
A.
A. B into B is A. Okay. And
C
C
into C
into
is also A.
is also A. Okay. But here A into A is coming as E.
E.
Just see the other type, that is here. Okay. ఇక్కడ ఏం చేసినాము? A into A, B into B, or C into C. Whenever I do this, okay, that is whenever I am doing A multiplied by A again, that means I am rotating. If I take C2B molecule, okay, uh, if I rotate 180 degrees, again I am rotating 180 degrees, I get back the same molecule, right? Identity, right? So same thing is happening. So all these are, or if I do the reverse, so again I will get back the, that is nothing but doing reverse, right? I rotate 180, then again I rotate 180 అంటే వెనకకు పోయినట్టే అవుతుంది. So
Yes, ma'am.
this is nothing but each, whenever we write A into A equal to E, or B into B equal to E, or C into C equal to E, this is nothing but each element is inverse of itself. Okay. So when you see this one, the one point you have to note down here is, whenever we are putting this way, we should understand that the element is inverse of itself. Okay. Now look at this one. How many you have like that? We have only one. Okay. So only one. What is that? A into A is only inverse of its element, whereas B and C are not inverse of its element because they are giving a different element. Okay, they are not giving identity, they are giving a different element. Okay. వినబడుతుందా? వాయిస్ ఇస్ క్లియర్?
Yes,
Yes,
ma'am.
ma'am.
So this is what we have done. We were able to write a group multiplication table for order number 4, okay, which clearly is having two different types. Okay. Now you can sit and practice. Simply, can you have any other way you can write? Okay. Either it has to be this one or it has to be the other one. Okay. But you cannot write one more method. If you take any method, it will be a repetition. Okay. So for G4 you have two types. Okay. Wherein all the elements, first case is all the elements are inverse of itself, where in the second case only A is inverse of itself.
Yes.
Okay. Okay. So these are the two things you have to remember. Okay. So we'll just take a point group, okay, and see how it is happening. Okay. So first one will take simpler one, that is C3. Okay, C3 as the point group. So same thing we have done. Okay. Now this and these are different. Can you see here? I have all the identity elements in the diagonal, whereas here the diagonal thing is changed. Okay. So either this or this. Let's look at the above group multiplication table for G3. Okay. So we have used this one, right, for G3. Suppose if you don't use that, that is A into A equal to B and B into B is equal to A. If I use the other way around, that is A into A is equal to B into B equal to E and A into B equal to B and B into A equal to A. The way we have done just now. Okay. What happens just you see? E into E is E. If these things are done as it is. Okay. Now A into A, what did we write? E. Okay. A into B is B. Now, B into A is A, B into B is E. Can you see here? Two B's and one E. Can
Yes,
you
ma'am.
see?
ma'am.
ఇక్కడ ఏమైతుంది? Two A's and one E. Is it a group multiplication table?
No, ma'am.
No. It should appear only once.
One.
So, this way of taking the multiplication is not giving you. Only this way of taking the multiplication is giving you. Okay. So, this is how you have to construct the group multiplication table. Okay. So, we'll just take one example. Okay. C3 తీసుకుందాం. Okay. C3 లో what are the elements? We have one identity. We have one C31. We have one C32. Okay. So, I'll just go to the whiteboard again. Okay. So, I'll take example C3. C3 lo elements.
A.
What are the elements I have? I have identity is the first one we have to write.
Identity. C31.
C31
C32.
and C32. C32 చేస్తే ఏమవుతుంది మళ్ళీ సేమ్ వచ్చేస్తుంది. మళ్ళీ it will come to its original position కదా.
Yes,
Do you remember మనం symmetry we have done? C33 చేస్తే 3 times rotate చేస్తే you will get the original structure. That is as if you have not done anything. Okay. So these are the elements. So E already రాస్తాం కాబట్టి so don't write C33 again. So again I have to write here E, C31 and C32. Okay. Now look at this. Now imagine we are doing a C3 on a molecule. Okay. Now you write the elements first. So ఏమవుతుంది ఇక్కడ E into E will be
Identity.
multiplied ఇక్కడ C31 C3 కదా.
Yes.
Anything multiplied by identity will be same thing,
Yes,
right?
ma'am.
Same element. One laga identity అంటే it's like 1 multiplied by 1. ఇక్కడ కూడా I will get C31 C32.
Secret.
But now we'll see what are the other things here. Okay. ఏమన్నాయి చూడండి. C31 into C31 ఏమొస్తుంది?
C32.
C32. Very good. So AB's కన్నా if you see this you will understand, right? So C31 C32
C3.
C31 and C32 C33 nothing but your E. Very good. Whoever is answering that. Yeah. Now C32 into C31.
E.
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 C31 C32 into C32 అంటే nothing but your C34 కదా.
Yes, ma'am.
అంటే C31. Very good. So we have C31. Group multiplication table. Did we satisfy the rule that
Yes, ma'am.
we are not repeating? Yeah. So what is the thing we have done here? If we are multiplying with A, if you take this as A, okay, if you take this as B, what did we get? A and B.
A into
What
A
did
is
we get?
equal to B.
A into A is equal to B. So what is the rule
Yes.
we followed here? A into A is nothing but B, not the E. Got it?
Yes, ma'am.
అంతే కదా ఇది A into A, you are getting B part.
Yes.
Huh?
Yes, ma'am.
A into B you are getting. What is the other rule you can write? What is the thing? A into B
Or
is
B
equal
into
to
A is equal to E.
or B into is equal to E. Okay. So this way or that way, commutative rule is there. Okay. And what else we are telling? A into A is B. Ante idi, this is not an inverse of itself, right? So you have two things here. Whenever you are writing like this, you call them as, whenever it is commutative, you call these A groups or elements as abelian groups. ఏమంటారు వీటిని?
Abelian.
Abelian. Abelian. Okay. That is, if I do A into B or B into A, I am getting the identity or same answer. Okay. May not be identity. If I am getting the same product, you call those as identity. Okay. This you have to remember. Okay. These are the abelian groups. Okay. So you are able to construct for C3. Similarly, you take for homework, you can construct for C2B, you do simple thing, you do C2B, then C2H, then C3V. Will you do, or shall I do one example for you?
We will do, ma'am.
I'll do. Okay, you'll do. Okay.
Yes.
It is available in the text. So you just do, you will get the multiplication table. Okay, for C2V, C2H. So for any group multiplication, you can do. Okay, but once you come to this, it becomes a little bit difficult. Okay, you should put the example, rotate and imagine and then write. Okay.
Okay.
Okay. Now we will go to the next smaller topic, that is group generating elements. This group generating elements means, so we know what a group multiplication table is. We know that we are writing a multiplication table for the point group, okay, and taking the rows and columns in the Latin where, okay, and we, in this particular group there will be a subset. So if you take the whole group as one set, then you will have one more small set of elements, okay, small number of elements which are very, very important or which define the whole group. Okay, with the help of that, you can develop the whole. You can develop the whole group. Okay, so you call such type of elements as important elements, or you call them as group generating elements. Okay, so you just understand, in a point group you will have so many elements. Okay, in that again I'll have a small number of elements which are very, very important. They themselves can give rise to all other elements. Such type of important or trivial elements, you call them as group generating elements. Okay, so it can be one, or it can be two, or it can be more than that. Okay, so we will just take an example, C3. Okay, so C3 లో ఎలిమెంట్స్ ఏమేమని చెప్పినాం ఇందాకనే, C31 E, C31 and C32, right? These are the three elements. So in this particular element, if I just write C31 is enough for me to generate E as well as to generate the other element. Okay, how do I generate E? C3, if I multiply C31 with C32, I will get E,
E.
right? Whiteboard will help you. So what I'm telling, in the C3 point group, okay, C31 is a important. Okay, so I am taking C3. I
Ma'am,
should be able
voice
to
break
produce E
అవుతుంది.
and voice break. I think, huh? Is it fine now?
Yes.
Then I'll remove this. So what I am doing now, I will take this C31, okay, and I should multiply. So this is a trivial element we are telling, okay. So what will I do? To generate other elements, first I'll try to generate E, okay. To generate E, I should multiply C31 with that of the C32.
C31 into C32.
What do I get?
E.
So I get C33, nothing but E. So did I generate using C31 the other element E? Okay. Then if I do C31 and C31, nothing but C32.
Yes.
Yeah. So I am using only one element to generate, or instead of using this C32, I can write C31 and remove C31 and generate E. Okay. So using one element, I can generate the other element. So which is the important or the group generating element for C3 point group is
One.
C31. Okay. In that way, every point group will have a some group generators. Okay. So C31 will give you E. C31 will give you C3. Okay. This is how we have generated. So this is going to apply for all types of CN groups. So if it is C41, again I will have C4 point group. I will have C41 is the important group generator. Like that, you can apply that formula to all the CM point groups. Okay. Now coming to this D3H point group, one more example we'll see. Okay. Now this D3H point group, these are all the elements. What are they? Identity C31. Now tell me what are the main things that is there in D3? D3 you will have one C3 and three C2s. That is why you call it as D, right? So
Yes,
you
ma'am.
have C31, C32, then three types of C2s. Okay. You have one horizontal axis, then you have three vertical axis,
Vertical
planes. Then you have two improper
axis.
rotation axis, S31 and S35. Okay. So these are all the elements in this particular point group. Now, what are the important elements in this are, which are group generating are C31 for these two. Okay. For all this, I will write C2, which is perpendicular to C31. That is why you called as C2 D. Okay. And the last one is sigma H. So if I take only 1, 2, and 3, I can generate all the rest of the elements. Only these three are the trivial elements. Okay. We are just showing that this C2 is perpendicular to the C31, the position. Okay. Okay. So we will take this one, C31. C31, can you generate E and C32? Just now we have seen. If I do three times, I will get E. Kada? If I do two times, I will get C32. So C31 is generating your E and C32. Okay. Now all these three are done. Okay. Now we'll go to the next one. C31 and C2 will give rise to all the sigma V's. What is happening? What is C3? If I'm having a molecule, let me go to the whiteboard again. Okay. So if I'm having a molecule, A, okay. So the axis is like this, passing through the A. Okay. So 1, 2, and 3. Okay. So what is that we are telling? We are telling that if it is passing through the C2, where will I have C2? Perpendicular to the C3 axis. Okay. That will give rise to the sigma V's. So we will just see what is happening here. So if this is the vertical one, okay, passing through the A. Okay, and if this is the one, the other thing will be the, so if this is a C3, can you see me? I don't know. Just one second. Wait. So just look at me. If I'm telling that if this is going to the A, okay, I've written A and all the other things here, right? So my other C2 axis will be like this, perpendicular. Can you see? So A is like this, the other axis is perpendicular to C3. Okay. What happens whenever I do a plane going through like this, passing through this one and this one, I will get all sigma V's. Okay. I will get all sigma V's. So to represent in this, we will have the little bit imagination you require. So along these, I have the sigma V's. Okay. And again to that, if I have a horizontal one, I will have a sigma H. Okay. So we are able to use C2 and C3 to generate the sigma V's, and C3 and C2s to generate the sigma V's, and C3 and sigma H to generate your other improper rotation axis. Okay, so the important or the group generating elements in this particular D3H is C3, C2 as well as sigma H. So only these three are enough to generate all other things. So in this way, you can take each and every point group, okay, and tell what are the group generating elements in this. Okay, this is already tabulated and given to you. So this is what you have to understand, that every group will have the some important elements which will can generate other elements. Okay, so you call them as group generating elements. Now we will go to subgroups. Okay, so group ante point group. Okay, in that again I will have a smaller group. I call it as a subgroup. Okay, so I can have many subgroups automatically. Okay, and they are known as the subgroups. As a whole, you call them as one big group. Okay, so a group within a group, you call it as a subgroup of the larger group. Now these subgroups can be of two types. Okay, these subgroups can be of two types. One is a trivial group. Trivial anangane, you should understand that we are talking about the which element?
E.
Very good. E. Okay, trivial element anteni identity. Okay, so trivial group is, it should have one element, only one element, and that is E. Okay, suppose if I'm having only one element, okay, and that order of that group is 1. Okay. Can you give me which point group will have only E? If I take C1, you will have only E. ఒకటే ఉంటుందండి. C1 అంటే rotated 360 degrees, right? So you will have only one element, that is E. Okay, you remember these are the low symmetry elements, point groups C1, CS, CI. CS will have only plane, CI will have only the inversion center. Okay, so here this will have only one element, that is E. This will have E and sigma. This will have E and I. Okay, so the trivial point group is the one where you are having the only the E. Okay, and order of that group is, that means only one element is present. Okay, the other ones will be, other subgroups will be non-trivial subgroups. Okay, in which E will be there automatically. Okay, and the order will start from 2. So trivial ante only one element, and that one element should be E, and order should be only 1. Whereas non-trivial means it will have E and the order will start from 2. Other than 1, you call them as 2. Okay, so you take these groups C1, CS, and CI. They don't have the subgroups. Okay, and the order is, for C1 it is only 1. Okay, now we will talk about this one. Example we'll just take. Okay, C3V. Now when you look at this C3V, what are all the point groups in C3V? C3V example, ammonia. Okay, so in ammonia, what is that I have? ammonia molecule, the elements will be identity C31, C32, sigma V, three sigma V's. So we mark them as sigma V prime, and sigma V double prime. Okay. Now look at these subgroups. So if I take C1, it will be identity. This is your trivial subgroup. Then the other subgroup C31, C32 and E. For CS you have, just see here, I'll write and show it to you, then it will be clear for you. So we are talking about the one, that is we are talking about the subgroups. We are telling that in each point group. So if I take C3V, okay, sorry, where am I writing V? C3V. So what are the elements I have? I have E. Okay, I have C3, 1,
C32,
C3, 2, and sigma V prime, sigma
sigma,
V
double,
double, double. Okay, so we'll take these three. Okay, and this is E. Now to represent this E, okay, I can write that this is nothing but this is a C1 group, subgroup. Okay, what does C1 represent? It has got only one, kada? It has got only one. That is nothing but your identity. I'll show you. Okay. Now to represent, that is what we have written here. The first one is this. Okay. Now I'll write the second one. I will write the next subgroup is C3. Okay. What does C3 consist of? Where did we write C3? C3 లో ఏమేమి ఉన్నాయి? E, C31 and C32. Okay, so I'm writing E is nothing, C3 is nothing but E, C31 and C32. Are they there in the, these elements are here, right? Kada? So I will tell that now. Just see, ఇప్పుడు ఎన్ని రాసిన నేను సబ్ గ్రూప్స్, ఒక సబ్ గ్రూప్, ఈ 3 ఒక సబ్ గ్రూప్. Can you make out? Do you understand now? So this main group is having how many subgroups, like that we will see. So I have just written only 2. So I can write for E as C1 as a subgroup, trivial one, okay, having only order 1. Ikkada you will have E plus order will be more than 1. So the order is 3 here. Okay. Next one, what did they write? Next one they said it is CS. CS prime and CS double prime. Okay. So what is CS? CS and it will have identity and one
sigma,
sigma. That's what I said. Yeah, C1 ante you will have only E, right? CS ante you will have E and
sigma,
one plane. Okay. CI ante you will have E and one inversion center. Okay. So what is that here? CS ante ఏంది? ఒక plane, ఒక identity. Okay. So సో ఒక ప్లేన్ ఒక ఐడెంటిటీ. Now I'll write one more. So this identity and one plane is here. So this and this. Okay. And if I write CS, I'll take one more color. It becomes easy for you. CS prime. దానికి ఏమొస్తుంది? I will have again one identity and one more sigma prime.
V prime.
Okay. So E and sigma V prime. Okay. Then one more will write.
CS double
One
prime.
more will write. Sigma CS double prime is giving me E. E అయితే అన్నిట్లో ఉండాలి కంపల్సరీ. రిమెంబర్ దట్. Then sigma double prime. So I have covered E and sigma double prime also. So this whole thing I am able to write in how many subgroups? 5 subgroups. Okay, we are able to represent. Okay, just remember this how we are doing. We will see the application in the later part. So each group is having some subgroups. So when you look at C3V point group, 1, 2, 3, 4, 5 subgroups are there, in which the first one is a trivial subgroup. The other ones are the non-trivial
Non-trivial
subgroup. Okay, here the trivial ante E compulsory untadi. E is there everywhere. Only E is present and order is 1. Here E is present and the order is more than
2.
1. More than 1, not 2. 2 ని కూడా ఉంది కదా. Okay. So 1 unte order trivial. More than 1 ante 2, 3, 4, 5. It will become non-trivial. Okay. Okay. That is what you have to understand. So this is having 5 subgroups. Okay. And these subgroups will together they will make a full groups. And you have to remember that these subgroups are, they are abelian antene they can commute with each other. Okay. Now subgroup is represented as small g. Okay. Now look at this. For each thing they have written the group multiplication table now. కదా ఒక్కొక్కటి ఒక్కొక్క గ్రూప్ అన్నప్పుడు ఏమవుతుంది? You can write for everything the group multiplication table. So the order of this group is 1, order is 3, order is 2, here also 2 and 2. Again they have taken one more example. D3H, it is having 12 subgroups. Okay. So this is about the groups and subgroups. Now next one is classes. So shall we talk about the classes in the next class?
Yes, ma'am.
Yeah. So today we have done. So I just started with the what are the main multiplication rules? Okay, closure rule, inverse rule, okay, commutative rule, associative rule, all this, and then we try to understand what is the group multiplication table. Okay, how we can write the group multiplication table. I have just shown you the example for C3. I have asked you to write for C2V, C3H. Okay, you can do that. Okay, as well as C3V. Then we understood what a subgroup is. Okay, we took an example and we have done. Okay, so with this background, you will be able to write the group multiplication table. Okay, is that okay? Did you all understand?
Yes, ma'am.
Thank you.